We've all seen it, the flawless curriculum planner. Key concepts and statements of inquiry perfectly aligned, cascading down the screen. But too often, those big ideas stay right there on the whiteboard. When the bell rings and the lesson begins, the momentum shifts, and the class falls back into memorizing a list of disconnected facts. Writing a concept into a syllabus guarantees absolutely nothing about how a student will process it. You can't just tell a learner what the big idea is and expect it to stick. Building real conceptual understanding requires deliberate architecture. It means using specific pedagogical strategies on the classroom floor to force students to grapple with the material. A concept is a working pedagogical tool, not a decoration for your planner. To get students to actually think conceptually, we have to guide them through a specific cognitive journey. That journey starts by forming the concept itself. Students need strategies to organize raw information into something abstract they can actually use. The first strategy is classification. This is where learners sort physical objects or phenomena into categories. Crucially, they have to explain their reasoning out loud. It's the difference between reciting a textbook definition and a student looking at a graph and arguing, this specific curve represents elastic demand because. Once they can categorize an idea, they use representation. This means applying multiple modes, like a visualization or a formula, to the exact same concept to reveal its core properties. If a student understands how to solve splitting a physical dollar bill into quarters, they can use that exact same logical structure to divide the number 100 by 4. Through classification and representation, learners stop seeing distinct, isolated facts. They start seeing the underlying shape of the information. With individual concepts formed, the next phase is building a structural architecture to connect them. This diagram illustrates the strategy of generalization. It builds from granular data at the base up to a broad idea at the top. Students link specific facts at the bottom, moving through topics and concepts, to construct a wider, transferable generalization at the peak. To make those connections visible, we use a strategy called concepts in use. This chart shows concepts in use in practice. It explicitly models how different ideas link together, establishing causal pathways between historical events or literary themes. By tracing from a broad key concept down to specific examples, students see how ideas interact dynamically rather than in isolation. Connecting concepts like this transforms a scatterplot of ideas into a functioning intellectual model that learners can actively manipulate. The final phase ensures this intellectual model sticks, so students can apply it independently to the unknown. This requires internalization. Think of a martial artist repeating a form thousands of times to transform a physical activity into a mental one. Through this, the underlying abstract strategy becomes an automatic response. This repetition builds the foundation for the final objective of the framework, near and far transfer. This graphic maps concept transfer from a central activity. Near transfer applies ideas within the same domain, like understanding scale across different instruments. Far transfer happens when understanding jumps to an entirely different domain, like using musical pitch training to learn spoken Chinese. When a learner can internalize an abstract idea and successfully transfer it into a completely unfamiliar context, they have completed the cognitive journey. The rigid, perfect curriculum planner we started with looks very different from the reality on the classroom floor. The classroom is a dynamic laboratory where students are actively mapping, classifying, and transferring. These 6 strategies, classification, representation, generalization, concepts in use, internalization, and transfer, form the necessary bridge between a written framework and actual student cognition. Conceptual understanding is a deliberate design choice that must be actively constructed by the educator within the lesson itself. Because when we teach students how to think with concepts, their knowledge isn't bound to the classroom. It can travel anywhere.